Hi, I'm Ian Porter.
I'm Jamie Simons.
And I'm Joey Susi.
For our Lab 3, we start off with a CAD drawing and some designs of bends that we think would be very structurally sound. This is the drawing that we ultimately came up with. It is a wire bent in a circle with a triangle kind of design to it, with open ends. This proved to be kind of difficult to make as the wire wasn't easy to make them all equal. They were all equal. This was also a very simple design as well, kind of bend using pliers as well as tools in the Maker Lab workspace. But also we ran into problems of asymmetry, which decreased the amount of weight that could be supported on our wire. Do you think?
We tried to go with like a circular base. We wanted to make it symmetrical, to make it as balanced as possible, but doing that in practice turned out to be pretty hard. That's kind of where we went wrong. But we went with this triangular shape because we figured triangles would be the most stable, they would resist distortion the most, as opposed to something like a rectangle. We wanted to keep the structure below its yield strength to prevent permanent deformation for as long as possible.
At first, I tried to bend U-shapes into the wire, but my first attempt snapped, leaving me with even less wire. This can be explained by the increase in dislocation density that occurred in the bends due to the plastic deformation, which led to a fracture in the wire. To shape my wire in the way I wanted, I used a 90-degree metal bending machine to form a zigzag pattern of plastic deformations in the wire, forming triangles without the base. I did this because I wanted the support to be as uniform as possible to eliminate any imbalances, and a machine is the best way to reduce human error. I then took the wire by the ends and did my best to connect them. Due to the difficulty that comes with using the metal bending machine and the fact that I had less wire to utilize, I was not able to make the ideal stand I had dreamt. Since I had no way to firmly connect the ends of the loop, the stand failed there. However, our CAD model is a closed loop and will perform much better since it is connected.
Well, technically we did it, which means if you want, you can take this to do the CAD. No, not anymore.
First one or the second one is like our probably the second one. Yeah. That one should be easy. That one would be easier. I know what I did for that. Yeah, like instead of
Why's mine working, dog?
Keep on going, Jimmy.
Yeah, these are 10 pounds each.
Probably should have each other numbers.
Oh yeah.
All right, it's not balanced well at all, but we're getting there.
Try like push down on the right side.